All right, I'm back, and so now we want to talk about the bonds that hold atoms together to turn them into a molecule. And so we've already done sodium chloride. So sodium chloride is an example of an ionic bond. In an ionic bond, you've got ions. One ion will be positive, the other one will be negative, opposites attract, and so that's an ionic bond. Now let's talk about another way of gluing atoms together, and this is going to be called a covalent bond. And so an example of this is going to be water. So water is H2O, so that means that it's got one oxygen and then it's got two hydrogens. Now you'll notice that I'm putting them at an angle to each other, and we'll explain that later. But for right now, I'm writing it like that, the way a chemist would. Now, how many electrons does hydrogen have? Each hydrogen has one electron. So let's illustrate that with an X. So that's the electron for this hydrogen, and then this is the electron for this hydrogen. And then let's represent the electrons for oxygen with a dot. Now, how many electrons, outer electrons, does oxygen have? Look at what column it's in, and that's going to be column 6. So that I'm going to represent this. Let's see, here's 1, and then 2, and then let's say 3 and 4, 5, and 6. So there's the 6 electrons. Now, what does oxygen want? What's the magic number? The magic number is 8. So oxygen sees hydrogens, 2 electrons, and it says, oh boy, I'm going to grab them. So let me put a dotted line here. And so if you count all of those electrons, you've got the magic number of 8. Now you might think that hydrogen, gets rid of its electron the same way that sodium does. Well, it's not quite right, because hydrogen and helium, their magic number is 2. Okay, and then, so let me use another dotted line here. So this hydrogen sees those 2 electrons and it says, I want them. And then this hydrogen sees those 2 electrons and it says that I want them. And those 2 electrons are being pulled back and forth because of the oxygen and the hydrogen. Those 2 electrons are being shared. So that's a covalent bond. So you'll notice that in the picture up there, there's a bill, money, and you got 2 people that are pulling on the bill, and they won't let go. So that's a covalent bond. In the second picture, that's a bill that's being passed from one person to another. That's the ionic bond. And now, what about the metallic bond? So that's the third major way that atoms are held together. Now, it says the word metallic, so guess what it happens in? Metals. So in a metal, let's illustrate a metal by saying that here's the nucleuses of a particular metal. So it could be iron, for example. And each one of those nucleuses is going to have electrons that are around it, that makes a cloud around it. And so every one of those irons is going to have a certain number of valence electrons. And those valence electrons can basically go anywhere that they want in the metal. So that for iron, it has like 2 valence electrons. So the 2 electrons from this nucleus right here basically can go anywhere that they want in the metal. And then the 2 iron electrons, the valence ones for this nucleus, well, they can go anywhere that they want. So that basically you've got trillions and trillions of electrons that are flowing around this metal. So can you see why metals are good conductors of electricity? Because those electrons carry the electricity through the metal. They're also good at carrying heat, so that metals are very good conductors of heat. Now later in the course we'll talk about what is conduction in more detail. So what I want you just to see that there's basically three ways of gluing atoms together to making a molecule. Now what we want to do is take the molecules and glue them together. So we'll do that in our next segment.